RMS, or root mean square, can be encountered in all kinds of situations, but today we're going to talk specifically about what it means in the world of electronics. First of all, let's take a look at a very basic electric circuit. Okay, so it's a power supply, a DC 1 volt power supply that is hooked up to a single 1 ohm resistor. So it's really basic. Now, if we would take a graph of the voltage and the time of this circuit, we would see that we have basically just constantly 1 volt all the time, which means if you do the maths, that means you get 1 amp of current, right? Because the current is the voltage divided by the resistance. They're both 1, so the current becomes 1 amp. If you would want to calculate the power dissipation of this circuit, you would do the current times the voltage, which is also 1. So the power of this circuit is 1 watt. Very simple. You could also do it in one step, right? So you can combine these two formulas so that you can get voltage squared divided by resistance is power, in which case you could also end up with 1 watt of power, right? It's very simple. It's very simple because there is a constant voltage and a constant current, and also, of course, a constant resistance, because the resistor isn't modified or anything whilst the circuit is running. So that's very nice. However, the story changes when it's an AC circuit. So now let's say we have an AC power supply connected to exactly the same resistor, so still 1 ohm. But this AC power supply doesn't have a constant voltage of 1 volt. No, it has a sine wave that goes up and down between plus 1 volt and minus 1 volt, minus 2. It goes up and down between plus 1 and minus 1 as a sine wave. Now this is complicated. It's complicated because the voltage is constantly changing. So here it's 1 volt, here it's 0, so there is no voltage, and then here it's minus 1. The current is also constantly changing, right? Because when the voltage is 1, the current is also 1. We've just calculated that. But when the voltage is 0, there is no current at all. And when the voltage is minus 1, then in this case the current is also minus 1. Which basically means a negative current obviously means that it goes in the opposite direction, right? So it changes, it's constantly changing. So if we want to see what the power dissipation is, the power dissipation is also constantly changing, right? Because here in the graph, the power dissipation is 1 watt, because it's 1 volt, 1 amp, 1 times 1 is 1. But here there is no power dissipation at all, because it's 0, right? The power is effectively turned off. And then all the way down here, the voltage is minus 1, so the current is also minus 1. Minus 1 times minus 1 is 1, right? So also 1 watt of power, which is logical, because if you have your resistor and the current goes in the opposite direction, it doesn't matter, right? There is still, the resistor warms up anyway, the power is always positive. So now we get to the point where we take a look at what RMS is. RMS is, the idea behind RMS is that we convert this AC sine wave signal into a fixed voltage, a fixed DC voltage that would give the same power dissipation. So basically the idea is that we have this weird sine wave that is not easy to work with because the voltage and the current are constantly changing. Therefore, we can take this sine wave and somehow convert it into a fixed voltage that is equivalent. Okay, so it's equivalent, so it's effectively the same. That's also why RMS voltage is sometimes called effective voltage, because it's effectively the same voltage, but because it's a fixed voltage, it allows us to do calculations more easily. In very basic terms, what this would mean is that if we have our AC setup here, right, that we just talked about, that AC setup has a certain power dissipation, a certain average power dissipation. Now then we have a DC setup right here, right next to it, and that DC setup has exactly the same resistor, so the same resistance, but it has a variable voltage controller, right? We can turn a knob to adjust the voltage. And now the question is, what voltage do we have to set that knob to on our DC power supply to get exactly the same power dissipation as our AC circuit? That's basically what this is all about. So first of all, it would be useful to find out what the average power dissipation is in our AC circuit. So how do we do that? Well, let's take a look at that graph again, shall we? Well, of course, the formula for finding power is voltage squared divided by resistance. We just used that in the beginning of this video. And the resistance is just 1, okay? So it doesn't really matter here. So the voltage squared is equal to the power. Brilliant. So let's square the voltage then, shall we? Except we do have to square all of the possible voltage levels. In other words, we square the entire graph, okay? So we get a new graph, which is the voltage squared, or the power in our case, because the resistance is just 1. So this new graph is a power graph, the power that goes up and down between 1 watt and 0 watts, as you can see. The next thing that we need to do is, because we're looking for the average power, is we need to find the average level of this graph, or the mean, as they call it. So the way you do this is you calculate the surface area underneath the graph and divide it by the time. And if you would do that on this wave, you would find that the mean is exactly 0.5. So 0.5 watts is our average power. Great, so we know that now, and that's very useful. Now, we can use this 0.5, this power dissipation, so we know that on our AC circuit, remember on this side, on the AC circuit we now know that we have 0.5 watts of average power dissipation. Now we know that we have to have 0.5 watt on this side as well. So we know it has to be 0.5 watts. And now the only thing that's left to do is reverse the formula we just used to find what voltage we need to do that. So 0.5 equals the voltage squared divided by the resistance. Again, the resistance is also 1 in this circuit, so that means the voltage squared is 0.5. In other words, the voltage that we need, the DC voltage to get 0.5 watts, is square root of 0.5. In other words, 0.7071, I believe. So that is our DC equivalent or effective voltage, also known as an RMS voltage. We had a 1 volt AC sine wave, 1 volt peak voltage, which goes up and down, and we've calculated that the DC voltage that would give the same power dissipation, also known as the effective or RMS voltage, is 0.707. Right? That's how it works. It's actually quite simple. So that's simply what RMS is. RMS voltage is the DC voltage that would give the same power dissipation as that AC signal. And it's nice to have that because then we can perform calculations much more easily. It's called RMS because the RMS voltage is the root of the mean of the squared voltage. Remember what we did? That's why it's called RMS. It's very clever, isn't it? Luckily though, if you want to calculate an RMS voltage, you don't have to perform all this maths. You don't have to calculate the surface area below a graph and all that sort of nonsense. You can just go on Wikipedia and find the RMS voltage for specific types of waves. For example, for the sine wave, the mean is always at the halfway point. So the RMS voltage is always equal to the maximum amplitude times root 0.5. So in other words, in a basic way, it means that if you have a 200 volt AC signal, so an AC signal that goes between plus 200 and minus 200, then your maximum amplitude is 200. So you do 200 times 0.707 and that gives you the RMS voltage. So you can just find the numbers in a table online. You don't have to do the maths all the time. That's very nice. And of course for current it's the same thing, right? The RMS current is the DC current that would give the same power dissipation as the AC current. Right? It's the same thing, but with voltage I found it's easier to understand. But there you go, now you know what root mean square or RMS means in the world of electronics. I hope you've enjoyed this video, and of course, thank you for watching.